Kia ora koutou. So I'm going to talk about something completely different. I'm a marine biologist by training, and when I started my scientific career 20 years ago, I did my PhD on ocean iron fertilization, which was at that time one of the most promising geoengineering methods. And when we did that research, so it's still a method that is part of the geoengineering proposals that are constantly discussed or reviewed. But back then, the general feeling I had and how I approached it, and also when I talked to colleagues, I think that was a consensus all through, that we all felt this is something that hopefully we won't have to do. So hopefully we can turn this ship around. Surely the IPCC was getting more international attention and political attention, and surely we will be able to solve this somehow and fix this, and it won't come to those big geoengineering ideas. But here we are 20 years later, and we haven't managed to turn anything around. If anything, it got worse. I mean, there are a lot of promising things here and there, but globally, big picture, we are definitely not there yet. And now we are very, very clear, the IPCC is very clear that we will not be able to reach our goals of limiting global warming to 2 degrees or ideally 1.5 degrees without significant amounts of carbon dioxide removal. So we definitely need offsetting, there's no doubt about that. How that looks like is another question. So when we talk about carbon dioxide removal or offsetting, immediately what people think about is planting trees. And that's great, there's nothing wrong with that, but we cannot plant enough trees. It's simply not possible. And also it's not a very secure way of storing carbon, because trees, first of all, they need a lot of land and a lot of water. There are a lot of co-benefits by doing that, healthy ecosystems, all that. As I said, there's nothing wrong. It's one tool in the toolbox. But when it comes to storing carbon for a long time, forests are very vulnerable, and especially in a changing climate, forest fires can destroy the work of decades in no time. So it's definitely not what's gonna solve this issue. So we have to turn our attention to other things as well and have a variety of different methods available or tools available to kind of limit our risks. So when it comes to carbon emissions and storing carbon, the ocean is really our best friend. First of all, the ocean is gigantic. It covers 70% of our planet, and it has already taken up naturally about 1/3 of the emissions, of the carbon emissions since the Industrial Revolution. So without that, we wouldn't even have the time to talk about how we can turn the ship around without the ocean, and that has really bought us a lot of time to do something. Not that we have used that time very well, but we can still do something. So we really need to turn our attention to the ocean more for this. And so when we talk about carbon sequestration in the ocean, again, it's mainly coastal, especially in New Zealand. I find the attention is very much the coastal ocean, which has a lot of cultural reasons. There's good reasons for that. But the largest part of the ocean is the open ocean. So again, we will not be able to reach the carbon sequestration that we need to reach with just focusing on blue carbon projects along the coastlines. Again, those are absolutely essential. We need to do them as well. And they have a lot of ecological co-benefits and social co-benefits, so no doubt about that. But the open ocean needs to be looked at, and we really need to have more of a discussion around how geoengineering in the open ocean looks like and what we want to do. So when I mention geoengineering, I usually get these two type of reactions. So first of all, people are kind of like, we don't want to do that, and it sounds scary, and it sounds like a science fiction thing, and a lot of things could go wrong. And there are some geoengineering proposals where I definitely feel the same. Like, I'm not going to talk about space mirrors, for example, and stuff like that. But the thing is, it's a reality that we're facing. One of those, at least one of those things, probably a lot of them are coming. And we really need to start the discussion around how we want this to look like And also, we really need to invest into the science and the policy side of things to do that safely and to monitor that safely. I also want to emphasize that, and one of the other reactions I often get is that, oh, we shouldn't do that, we shouldn't look into that because then it creates complacency and we won't invest or we won't put enough effort into preventing carbon emissions and reducing carbon emissions. Definitely, that is one thing we need to do, and that needs to be our main focus. So every ton of carbon that we keep in the ground and that we don't burn is one that we don't have to remove later on. And it's much, much easier and safer and cheaper to reduce emissions than it is to then try to recapture the carbon. Nevertheless, we have to do both, because we need, if we want to reach net zero emissions, we have to offset some of it. So coming back to the gigantic open ocean, one of the more new geoengineering ideas that involves the open ocean is ocean alkalinity enhancement. So that is a proposal where sometimes it's referred to as ocean liming. Some of you might have heard of that. So it involves adding certain minerals like olivine or quicklime, or you could also use steel slag in a fine powder to the surface ocean, and that changes the ocean chemistry in a way that chemically more CO2 can be taken up. One of the massive side benefits from that is that it counteracts ocean acidification, because in this process where CO2 is taken up by the ocean, ocean acidification is happening, and it significantly reduces the seawater pH, which has massive impacts on ecosystems. So ocean alkalinity enhancement would be one way to sequester more carbon into the ocean and also to counteract ocean acidification, so it has a significant co-benefit there. It also doesn't directly impact any biological process, so that would be a benefit as well. But we are at the very, very beginning, really, the chemistry is very clear, it's simple, the modeling looks very, very promising, but scientifically we are quite in the beginning of this, and there are a lot of questions that we need to answer scientifically. We haven't had any large-scale open ocean experiments. Most of the research is small-scale in coastal regions or in the lab. And also we need this discussion about legislation, because when we are working in the open ocean, things are becoming a lot more difficult. I feel that especially in New Zealand, because we are relatively more isolated from other countries, we have this very inwards-looking approach to a lot of things, which can be really good because it creates this kind of feeling around we are in this together and we work on this and we have this New Zealand focus, which I really applaud. But we are also part of a global community, and we really have to approach this as a global community. So we have to have this open conversation about what are the risks and benefits, what do we want to do as a society, while we are, of course, reducing emissions. That should definitely be our main focus. But we also cannot close our eyes about what is coming, and we have to think about what are the risks if we don't do things like this. Geoengineering is something that we have to approach, and I don't want any kind of crazy billionaires at some point taking things in their own hands and starting their own things. So we really cannot close our eyes and sit tight and not do something. We, as a scientific community, together with policymakers and the general public, have to have this conversation and have to really look into those things. And I quickly wanted to mention, am I running out of time, or? Okay, just quickly. So at the moment, what the scientific community is working on is very clear guidelines about monitoring, reporting, and verification. So, of course, when we're working on a global scale, it's a little more complicated to really monitor what is happening, the processes, how much carbon is sequestered. Then we need good processes to report it. Just publishing it in the scientific literature hasn't really proven to be the most efficient way to reach policymakers and the general public. And then we need third-party verification that what we are saying is happening is actually happening. So those are the processes and the kind of best practice guides that are currently being established in the scientific community. Thank you.